Hello everybody. In today's lecture, let us talk about wave velocity, group velocity and wave packet. Wave velocity or phase velocity. Right? When if we take a monochromatic wave, monochromatic means, do you know what is that? So monochromatic wave means a wave with single frequency and wavelength, that we call it as monochromatic wave. If this monochromatic wave travels through a medium, its velocity of advancement in medium, we call it as wave velocity. So what is velocity? Wave velocity. The velocity of a monochromatic wave when it travels through a medium, the velocity of advancement in the medium of monochromatic wave while traveling through a medium, we call it as wave velocity. And now this wave velocity is also defined as, we indicate with Vp, okay, the ratio of angular frequency to the propagation constant, angular frequency to the propagation constant, propagation constant. Now in such a way we define the wave velocity, right? Now if we take a wave of face value omega t minus kx, here we are taking wave of face value omega t minus kx. So for planes of constant phases, that is nothing but wave fronts, omega t minus kx will be constant. Okay, so if we differentiate this equation with respect to time, then we get omega minus k dx by dt equal to 0. Okay, or omega equal to k dx by dt, or dx by dt is equal to omega by k. What is dx by dt? Nothing but velocity. Dx by dt is nothing but velocity, that is equal to omega by k. The same thing we proved, the ratio of angular frequency to the propagation constant. Now here, thus P for phase, thus the wave velocity is, we can also define it as, wave velocity is velocity with which planes moves with constant phase. The velocity with which the planes of constant phase advances through the medium, it is nothing but the velocity with which planes of constant phases advance through the medium or move through the medium. We call it as phase velocity. Right? Now let us move for group velocity. Okay? So group velocity, if we consider pulses rather than monochromatic wave, number of waves you take, pulses we are taking instead of monochromatic wave. So these pulses consist of some number of waves, and these waves differ in frequency, from each other, means they are not having same frequency. Pulse means it is nothing but consists of number of waves of slightly different frequency from one another. The superposition of all these waves, we call it as wave group. What is wave group? The superposition of all these waves, we call it as wave group, or we call it as wave packet. Okay, when such group travels in the medium, when such group of waves or group travels in medium, the phase velocities of different components are different. How will be the phase velocities? Different for different components. Okay, so now the velocity with which the energy in group is, the velocity with which the maximum amplitude of group advances, we call it as group velocity. So what is group velocity? The velocity with which maximum amplitude of group advances, or the velocity of this group, we call it as group velocity. So thus group velocity is the velocity with which energy in group is transmitted. What is group velocity? It is the velocity with which the energy in group is transmitted. So what is wave velocity or phase velocity? Wave velocity, if a monochromatic wave advances in the medium, okay, the velocity of that wave, we call it as wave velocity. Okay, if the velocity with which planes of constant phases advance through the medium, we can call it as phase velocity also, which is the ratio of angular frequency to propagation vector. Now group velocity means we are considering pulses instead of monochromatic wave. Pulses consist of number of waves of slightly different frequencies from each other. So these wave groups superimpose on each other and advances in the medium. So that velocity of the group itself only we call it as group velocity. So here group velocity can also be said that the velocity with which the energy in group is transmitted. The energy in group is transmitted. Now let us see the expression for group velocity. So group velocity, it is written as Vg, G for group, d omega by dk. That is omega minus omega dash by k minus k dash. Right? Now the relationship between group velocity and wave velocity or phase velocity. So the relation between them is, note down these formulas. That is Vg is equal to Vp minus lambda dVp by d lambda. This is the relationship between group velocity and phase velocity or wave velocity. Also we can prove that the de Broglie wave group associated with moving particles travels with same velocity as particle Vg equal to V. The de Broglie wave group associated with moving particle travels with same velocity as particle. Group velocity is equal to particle velocity. We can also prove this. Right? Now next, let us see about the wave packet. Right? Here only we said wave group or wave packet is nothing but same. Now let us move for wave packet. Okay. Now on x-axis displacement, amplitude on y-axis, right, in such a way. Okay, now this we call it as wave packet. This we call it as wave packet. So what is wave packet? It consists of group of waves. Okay, it consists of some group of waves slightly differing in velocity as well as wavelength with phase assigned amplitude. Okay, with phase assigned amplitude. This is nothing but a group of waves slightly differing in velocity and wavelength with phase assigned amplitudes in particular region. We call it as wave packet. Okay, now inside this small region they interfere constructively. Okay, so over a small region of space, here a particle can be located. In this we can locate the particle because inside this region these waves are interfering constructively, but outside this region the waves interfere destructively. So amplitude reduces and becomes 0. Amplitude reduces towards 0. Now such wave packets will move with their own velocity, that we call it as group velocity, right? The individual waves forming the wave packet have average velocity. If we take the individual wave packets and if we take the average velocity of that individual wave packets, that give rise to the phase velocity. Okay, and we can also say that the velocity of material particle is equal to the group velocity, same as group velocity. So what is wave packet? Nothing but the group of waves in a small region which differ in velocity as well as wavelength and having phases and amplitudes. That we call it as a wave packet. So actually inside the wave packet, due to the constructive interference of waves, we can locate the particle. But outside this region, there will be destructive interference, so amplitude reduces to 0. So this is about the wave packet, wave velocity and group velocity. If you like my video, like it, share it, subscribe it. Thank you.